Okay, example 5 is you have to, first of all, you have to have a polygon. If it's not a polygon, you don't worry about if it's convex or concave that often. You could talk about it, other shapes being convex or concave. And here's what I think of for convex and concave. I know it's not the formal definition, but a cave goes into a mountain. So if a shape bends inwards, you get kind of a cave into it, so I know it's concave. And then the opposite is convex. So I think of a cave going into a mountain. If it looks like it's kind of, the shape sort of bends into itself, it's concave. Okay, so I'm going to erase those things. I'm just erasing that off. And we'll go and work on these problems. First of all, this problem here, when I look at it, it fails the definition of a polygon right here. Right here and here. Remember, the definition can have, it only intersects two segments, but here we have intersecting, well, not very good writing. Intersecting three segments. At one endpoint. So I know this is not a polygon, so I don't have to worry about convex or concave. Although, if we look at it, use a different color, it does bend in. It bends in, so it's probably, if I were to call it something, it would be concave, but it's not even a polygon, so I don't have to worry about it. Okay, the next one. Well, it meets the definition of a polygon. It looks like it's some kind of hexagon. It's got 6 sides, so it's a hexagon. Okay? And it seems to bend out. There's no bending in. Now remember, the definition says you take non-consecutive vertices and draw diagonals. So I drew a diagonal here. I can draw a diagonal here. I can draw a diagonal here. I can draw diagonals here, 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 here. You know, I can go over here. I've basically drawn all of them, other than I'm messy at drawing. They all are interior. So this would be a convex polygon. Okay. C. Looks like a funky shape. Problem is, this is a curve or an arc. It's not a polygon. If it were one, it would be concave, though. It would be concave on that one, because if I draw the diagonal, this one is outside. It's partially outside, okay? The last one is a polygon. It looks like it's got 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10, 11, 12 sides. Okay, so it's got 12 sides, so it's a dodecagon. You didn't have to call it anything, but we'll practice it because that's part of the section. It's do meaning 2, deca meaning 10, 2, 10, agon. Okay, now, let's use purple here. Are there diagonals, so connecting non-adjacent vertices, non-consecutive vertices, that are partially or fully on the exterior, outside of the shape? Well, that's interior. That's interior. That's interior. That's interior. That's interior. This is right on the edge, so it's interior. So is the next one to it. Okay, so someone might be inclined to say it's concave. Convex. Okay, but let's pick some other ones. So if I were to pick this one here, whoops, got to get my writer. 1. Oh, goes outside. That one's okay. I just need one to go outside the shape. And then again it goes outside. So it goes outside in these ones right here. I'll put them in green. This one goes outside. As soon as I found one I should stop. I just decided to go through. Or that one. Those are diagonals that are not completely inside the shape. So we know it is concave. Okay? Now if I were, there's a faster way to do that though. So I'm going to erase some of this stuff. This is that idea of a cave bends into a mountain. Well, if you look here, if this shape were like this, originally it looks like it bent in here, it was pushed in here, it was pushed in here. So it's like someone took a bite out of it, or it's going into it like a mountain. So I also know it's concave. So I think that's easier to do it that way. Sometimes it's confusing. But the definition says the diagonal, as long as one diagonal goes outside or partially outside, it's concave.